10-foot sections that you're doing these like fairly straight lines, like they're as close as you can get them to perfectly straight. That when you're matching these sections together, like if they were hinged, if there's a very minor deflection between the two lines, so between the two 10-foot segments, then that would take out, essentially, that would remove how perfectly straight your line is. It could curve, and you'd actually have to physically measure between panels. Like you'd have to get a tool that's 20 foot long that has the precision to
No, they're all
measure.
flush. There's no gap. All the panels are like flush. You know what I'm saying?
I mean, they're not going to be, if they're hinged, they're not going to be perfectly flush, right?
Yeah, you get them close though.
Yeah, but if you're talking about like even less than a 64th of an inch deflection on these things, then over the course of half a
But
mile,
deflection of what though?
the two lines, because you have to get the two lines perfectly in alignment with each other, right? Well, not perfectly, but very, 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 very close.
Yeah, like if you say you have two of them, let's just use two for now, just to make it easier. You
Yeah.
got two 10-foot sections. You lay them both
Mm-hmm.
flat. You snap your line. You put them both up. You're
Mm-hmm.
saying it's going to curve?
I'm saying it has the potential to curve. So, like a 20-foot section, I know I've run the numbers for like 150 foot, and it was like less than 1/64th of an inch. That like the Earth, if the Earth is a globe and it's the circumference that it's purported to be, so you'd have to be able to measure that your two lines are in alignment greater than like your margin of error has to be smaller than that deflection. Do you get what I'm saying there?
Yeah, I don't see it being an issue really. Like, bro, if we did that for hundreds and hundreds of those panels, and then you
Mm-hmm.
put the thing up, do you think it couldn't accidentally be curving at 8 inches per mile squared, right? So, I mean, I feel like you get a pretty definitive result after that. No,
I mean, it depends on how you're drawing the line, because you can't just pick like arbitrary points on the panels that you're drawing. Presumably, you would
we're
do
gonna
it.
snap it. We're gonna snap a line. Well, here's what you would
Yeah,
do. You would take the middle
yeah.
panel. You would take the middle
Mm-hmm.
panel and make a level line in the middle. Then
Mm-hmm.
you would snap your line on top of that line for all the panels. You know what I'm saying? You wouldn't use level anymore, but
Well,
you want to make your middle point be the level point.
like the flat point is what you're trying to
Level.
say.
Well, no, you want to make the
Well,
middle one be level so that way you have symmetry on both sides. Like you want to get down to both
mm-hmm.
ends and be able to measure up. Okay, you know what I'm saying? You want to make sure they're symmetrical with your level line.
Yeah, yeah. That's kind of what I'm getting at. Is let's say you put it 2 inches above the central panel, just so you have like a reference point, like so that they're not actually touching each other, so that you could go down hypothetically to the last panel and measure 3 inches or 2 inches or whatever it happens to turn out to be. But in order to get that perfectly straight line established, you would have to do each line. Like you couldn't measure 2 inches above the horizontal line that you have, because then you'd just be retracing that same line, right? Like how would you know where to strike each flat line? I'm going to call it the flat line, the one that you're talking about that's perfectly straight.
Yeah.
How would
You
you
make the
know
level
where to
line.
mark it on each 10-foot panel?
You're going to do it all at once. Like I said, you get the middle panel in the middle of this 3 mile, let's say, string of pieces. You know what I'm saying?
Yep.
And your wall. You go to the middle point. You make a level line, and then you just snap your horizontal. You would snap your flat line right on top of that line. That way, you know you're level in the middle.
Well, I mean, the
There's
line's
no
going to be
difference
level
between
at all
level.
points.
My horizontal line.
Yeah, let's call it a horizontal line and a flat line, just so we don't mix up the terms.
I mean,
The
if you think the
horizontal line, you're
horizontal,
just sorry. Go ahead.
if you think the horizontal line is going to be level at all points, then you're on my side. And I don't know.
Yeah, I mean that's the globe. Under the globe model, level does mean conforming to the curvature of the Earth.
Yeah, so
It
the
doesn't mean
horizontal line
flat.
wouldn't be level. So the horizontal line wouldn't be level at all points.
No, the horizontal line would be level at all points. It's the same distance from the center of the Earth.
Bro,
I'm just telling you what the
dude.
definition
If
is.
I
Like
if I
I
make
don't.
a straight line, dude, if I make a horizontal line, that can only
Mhm.
be level in one spot on the globe.
No, the horizontal line curves according to a globe model. A flat line would actually like depart from. It would only tangent
Hold,
of
hold on,
a
bro. You're chopping
given
up. Did you just
circumference
say that?
sphere.
Hold on, you're chopping up. Did you say the horizontal line curves? Did you say that, or did I mishear you? Finland. That's a weird name to even say. Finland. Can we change your name to Finland? It'd be easier.
Am I roboting or is that Jeremy? I can't tell.
Oh, it
I
could be
lost that
me.
for
I
a
don't
second.
know. I'm in a Faraday cage. I thought it was you, but I don't know. It could be me. I thought it was you, but try it again. Go ahead. Did you say the horizontal line curves, or what's up?
Yeah. The horizontal line curves. It's just the same given distance from the center of the Earth. Yes.
Yeah, bro. That's not how a horizontal line works on the globe.
All right. Well, let me just go with my definition then, just for the sake of the discussion.
I mean, bro, if a straight line is level, then I don't like you're on my side, like I said earlier.
No,
If
I'm
you think
saying
we
it's
make a, if
a
you think
level
we can
line
make a
is not straight.
the level line, yeah, but we're talking about the horizontal line. Dude, don't worry about the level line. That is literally the easiest part. I could have a child make us the level reference. Don't worry about the level reference. It's the horizontal one
Sure.
we're worried about.
I thought the horizontal one was the one that would be like if we did this wall over what's it called? Like standing water where it's not perturbed at all. If you did that, that would be like if it was 6 foot up from the water at all points, that would be the horizontal line. But now you're saying, but let's just make sure we're using the same words for what we're talking about.
The horizontal line is going to be a straight line on flat Earth
Okay.
that will be level at all points, and it will be the same distance away from the level reference we make. On a globe, the horizontal line will be deviating from it'll be converging and diverging from the level line.
Okay. So you're using, sorry, I don't know why I'm having a problem with this. Level line
I
is
don't.
flat.
Nope.
That's what you're
Level
saying.
line.
Level
No.
line would
I'm
curve
saying the
for a
level.
globe.
Yes, and it'll be
All right,
straight
go ahead.
for. It'll curve for the globe, and it'll be straight for us. The way to tell if that's happening is by this horizontal line, straight line that we're going to make
Okay.
by snapping
So
a line
horizontal
on the
and straight
panel.
and flat. Okay, I got you. I got you. Sorry.
Yeah. So if you flipped all these panels, right?
Hmm.
You lay all the panels down. You make your horizontal line, or you snap a chalk line on all the panels, and then you lift the panels up. Yeah, there might be a little wiggle and a little play, but it would have to be eight
Hmm.
inches per mile squared. I feel like this would be a pretty definitive result. So I don't know.
I mean, it could be. It has the potential to be, but the only thing I'm trying to stress is the margin of error. Like you'd have to get these things very precisely fitted because if you're putting in 10-foot panels and there's a deflection of way less than a
But where
64th of an inch, then it could deflect toward. It could deflect into what's it called? Away from actually being perfectly straight, perfectly flat.
Yes, it might not. I understand. When we have the panels laying down, it'll be a pretty close to perfectly straight line. There's no perfectly straight, but it'll be very close to a straight line. And then when you lift the panels up, I realize there may be a little wiggle room and there may be some
Mhm.
shifting and things happening. However, you got to get 8 inches per mile squared. So if we get 2-3 miles of this, I feel like it'd be pretty definitive on the answer.
Sure, if you were able to have tight enough controls, sure, I'd be
Well, I
willing to
mean, even
agree
if
to
the
that.
controls aren't that tight, like I don't, it would have to just coincidentally be, your error would have to coincidentally be first of all, a squared function, which is unlikely.
Mhm.
You know what I'm saying?
Sure.
Like if you're off, let's say you're off an eighth of an inch every panel, that's not going to end up being a squared function.
Yeah,
So I don't know.
sure.
I feel like that's pretty definitive with the vertical, with the hinged walls. That was one of my better ones, I thought.
Okay. And that's kind of like what I was bringing up. Like, what would your methodology be for striking that flat line? Because
Well,
if you're
that's
just trying to
one.
like, go ahead.
That's one of the methodologies right there. You know, the hinged wall. That could be one way you get a straight line on the wall.
Hmm.
That's what I'm saying, bro. Scott V. You know what Scott Veach is?
I can't say I've heard the
It's not
name.
important. It's not important. Son of an astronaut. He used to say that. He used to say that he thinks a machine can do this, like a robot and a machine could actually make this straight line. I wasn't too sure about it. He was pretty confident. He had like a PhD in like, I don't know, some kind of computer shit or something.
Okay.
I think the hinged wall would give your best result, honestly.
I think it's possible. It'd just be the engineering would be very, very difficult on it. But I get the point of what you're saying.
I don't think it's that difficult, dude. I think I could do it with Legos. It's like-
I mean, you've used Legos before, right? Like you can move them a little bit, and they'll stay together. Like they're not going to be
yeah, there's some
perfectly straight and
shifting.
flat.
There's some
Hmm.
shifting. I hear you, but if you have a whole mile of them all on hinges and stuff, like I said, once you snap your line when they're laying flat, once you lift them up, yeah, you got a little wiggle room and stuff, but we're looking for 8 inches per mile squared. That's very specific. It would have to be something close to that, you know? And I don't feel like you're going to get a squared function as your error bar, right? It's just going to be your error bar is this or it's that, or your error bar is 8 inches per mile or 3 feet per mile or something. It's not going to be like, do
Hmm.
error bars have squared functions? I don't know. I don't think so. Maybe.
Well, I mean, the the vector of gravity pulling down could cause the measurements to like force down into being the same distance from the surface. I get what you're saying. It would be strange that all of them would coincidentally match up to what the curvature of the Earth would be. I think you'd have to come up with like a really solid methodology to mark that perfectly flat line because if you're taking all the panels off, like I think the best way might be you take all the
Making
panels off simultaneously, lay them in a line, run a string across them, spray paint that string so that you have a clear white line. But even then, you wouldn't be able to like if you then picked up that entire wall at once or in sections and put it back on top of the preset base that you have, it could curve over that distance and you wouldn't really be able to tell, especially if you're not using optics.
That's what I'm saying. You build the hinged wall, you let it settle. You know what I'm saying? Let it settle for a couple weeks, couple months, whatever it takes. Now you just have a wall
Sure.
there. Then you
Hmm.
just fold them down. You just fold them down on your hinges. You know what I'm saying? And then you make your
Yeah.
snap your line, and then you put them back up on the hinges. I feel like if there is any shifting, it's going to be so minimal. It's not. I feel like there's going to be a clear result here. I don't know. Maybe it's just me. Like I said, I feel like I could get a clear result honestly with Lego block. If I had 3 miles worth of Lego blocks, I feel like I could do this. Those flat bases you used to build your Lego houses on, the
Mhm.
plates. Give me like
You
3
ever
miles worth
see?
of those.
Yeah, yeah. There's just a lot of flex in them. But you ever see like the machinist tools for gauging steel thickness, or what they used to use in old
Calipers,
times? Yeah, yeah, calipers.
or I think they have another name too. I forgot the other name of them.
Yeah, there's one for
Micrometer.
like, yeah, yeah, something like that. But I would think it would
What
almost
about
be
it?
easier to get an instrument that like just take a flat, fairly large body of water, and then over a 3 foot distance, see if you could actually measure, get an instrument that's precise enough to measure what curve would be inside that 3 inches. Or sorry, not 3 inches, 3 feet.
You
Because you could
can't, dude. It's
hypothetically
too
put,
small, bro. It's too small. We're 3 feet. You're looking at like you're looking at like fractions of a
nanometers.
millimeter. Yeah,
Yeah, yeah.
you're into nanometers, probably. Yeah, bro. You ain't gonna get nothing to measure that.
I mean, we can measure nanometers. We do it all the time. I. It's just a question of like, can you do that over such a like over a 3 foot distance? Can you measure a deviation from flat? But I would almost think that that would be an easier, more definitive. Uh, well, maybe it wouldn't be. You'd probably have to make it out of a particular material because water will uh, like stick to a surface, so it could rise or lower. You might have to use something else. I'm kind of curious. I'm gonna look up later if there is like such a tool that you could do that you could use to do that. I know there's definitely stuff you can use to like do within. I think it's 64ths over like a 8 foot area, but you got to get way smaller. Do you like that idea at all, Jeremy?
I mean, you still have to make your horizontal line, dude.
You use the water for the horizontal, or you could like pour a metal at extreme temperature so that it
Dude,
comes
if the
out.
water is the you're getting confused on what, like, I'm not trying to ad hom you or insult you, but you're getting confused on what horizontal and level is because it sounds like you're on my side when you say stuff about.
Like that idea at all, Jeremy?
I mean, you still have to make a horizontal line, dude.
Yeah, you use the water for the horizontal, or you could like pour a metal at extreme temperature so that it
Dude,
comes
if the
out.
water is the you're getting confused on what, like, I'm not trying to ad hom you or insult you, but you're getting confused on what horizontal and level is because it sounds like you're on my side when you say stuff about horizontal and level.
Yeah, I'm probably mixing up the terms the way I'm using them, but what like the horizon, or like if a level line is flat or if it curves.
Bro, your horizon is flat. I don't know if you knew that or not, but on a globe, the horizon's flat.
No, it's not.
Yeah, it is. It's a flat circle.
No, I mean it does curve. I've seen it.
It's not, bro, the horizon. I'm telling you. Yes, you would see the curve
Yeah.
of a flat circle if you were above it. Yes, but your horizon on the globe is just a flat circle,
Mhm.
bro.
I mean, you can measure the. I mean, you don't like optical stuff, so you're not going to really accept what evidence I would present. But there are ways that you can measure to see if the horizon is actually flat or if it does curve slightly.
Dude, you don't get it, bro. In the globe model, it's a flat circle. Like, I didn't make that up. I'm not straw manning it. That's the steel man of the globe. It's a flat
I'll send
circle.
you something later if you want, where it's shown it's measured to be curving. I've seen it myself.
I understand that. If you get above a circle, it looks like it's curving. Yes. However, physically, in reality, on a globe, it would be a flat circle.
No, it curves. Like I'm not talking about going up super high. I think the observation that I've seen was 673 feet, something like that, 600, 700 feet.
Bro,
And
it
if
doesn't
you
matter
put
how
a
high up you
level
go.
up
Sorry.
to the horizon, you can actually see that the level itself, whatever flat, perfectly flat object you have, up butting up next to the horizon stays flat, but the horizon curves left to right. We're talking about
Because
left
you're
to right
above,
curve, right?
because you're above, yes, because you're above a circle. We both agree it's a circle around you, right?
Yeah, so it would curve.
It would appear to curve, but it would be flat. Circles are flat. I'm
Well,
telling you, dude,
circles
on the
are two
like I'm not
dimensional,
trying
so
to
yes,
mess
of
with you.
course they're flat.
Like I'm not trying to mess with you, but on a globe, it's a flat circle.
Mhm.
It's not curving the left or right way you think it would be. It doesn't do that. It doesn't matter how high up you go. If you went through 30 miles up, it's still you're still just looking at a circle, a flat circle.
I I've seen measurements of the horizon curving. So, do you have measurements of a flat horizon?
I mean, you would debunk the globe model if it was curving the way you thought it was because it has to be a flat circle, bro. There's no
So,
elevation change. Like there actually is elevation change in your horizon. There's elevation change. If you had an all level, if you were in the middle 3 miles each direction, all level, there's an elevation change there in the horizon you're looking at.
I don't understand what you're saying. You're saying my horizon is always 3 miles?
No, I'm just saying if you're a 6 foot guy, bro, I'm telling you, the horizon on the globe, right? Is
Uh huh.
I'm trying to think of the best way to explain this to you. Uh okay, here it is. You can see in 3 miles, right? So 3 mile, if you look
Sometimes.
directly ahead of you, yeah, if you look directly ahead, let's just say you're 6 foot and it's supposed to be 3 miles, and we're in the conditions where
Sure.
that's what it is. Yeah, so you're
Yeah,
looking
I'm with
ahead
you.
of you. You're 3 miles. You're standing there. You're looking ahead. It's all level surface. You're looking 3 miles ahead of you, right? Let's say sorry. Let's say
Okay.
the horizons. Let's say, just for the ease of math. Let's say the horizon's 1 mile. Then we can just use
Okay.
8 inches. All right, cool. So you're looking
Sure.
straight ahead.
Hmm.
You're looking straight ahead. There's an 8 inch. The point you're looking at, the last point you can see the horizon, is 8 inches below you, right?
Uh, yeah, sure.
Okay. Did you say yes, sir? Yeah, sure.
Well, it'd be 6 foot 8 inch, right?
Yeah. Okay. Fine. Yeah. 6 foot 8 inches. Yep.
Sorry, I'm being a bit pedantic. Sorry,
It's
go on.
fine. No, it's fine. It's better to be clear. It's better to be clear it all up now, so we're not confused later. 6 foot
Sure.
8 inches beneath your eye level. Cool.
Hmm.
Okay. Then
Yep.
you turn to the left 90 degrees and you look straight ahead.
Yep.
That is going
Yep.
to be 6 foot 8 inches beneath your eye level. Right. And you could turn all the way around, and
Yep.
every point you turn, it's going to be 6 foot
Hmm.
8 inches beneath you.
Yep. Correct.
Yeah, that's just a straight circle, a flat circle.
Sure. And if like you're looking at
Maybe
a
that wasn't a good
basketball,
way to.
no, I get what you're saying.
Yo,
But if
yo.
you're looking like
Okay.
at a
Oh, basketball's good. Basketball's good. Let me just run you through this one real quick. Real quick.
sure,
You're an ant on a beach ball. You're an ant on a basketball.
go for it.
Your horizon is 3 inches from you. I take a coffee
Mhm.
cup, right, and draw a circle where the horizon is for the ant. Um, that's just going to be like if you were to chop that off. the part where the ant's standing, yeah, that curves up to him, but the horizon itself is just going to be a flat circle because you could chop that off, and the part you're seeing would all be in a plane. They call it the plane of the. Have you ever heard the term the plane of the horizon?
I think so.
Yeah, that's what I'm saying. They're telling you it's a plane, bro. It's not curving the way you think it is. It's a plane. It doesn't curve.
Well, I mean, it does curve because, like, if I take a basketball and I got it really close to my face, or if I like put my eye right up to the surface, I'm gonna see the line curving left to right and it being highest at the center point, like at this where I'm looking directly ahead. And if I start to move that ball further and further away from my face, instead of me seeing a small cross section of that circle, I'm going to start to see more and more and more of that. So it actually becomes a circle all the way around.
Yeah, and every
But
time you see more and more and more,
yeah, but if I take a
every
picture
time you see.
of an extreme close up of that basketball, I will be able to see the left side falling off to the left and the right side falling off. Yeah, the right side falling off to the right. So it would show curve when you're really, really close to it.
Yeah, but that's not the kind of curve that we're looking for. That's the curve that would happen if it was flat as well.
Uh, I mean, if it was perfectly flat and you kept getting further and further away, I mean, I guess it depends on what the Earth itself looks like. Like if it's a square, if you could see enough of it. Do you think you could ever see the whole planet at once if it's flat?
I don't think so. No, I think there's optical effects happening that just won't let you do that. The universe like wants to keep you in the dark. Are you familiar with the like the de Broglie wavelength or the delay or the double slit? Bro, I'm telling you though, if you get one of those styrofoam balls from Joanne Fabrics, put your eyeball down, right? Eyeball down to the ball. If you were to make a circle around where your horizon was and chop that part of the ball off, that would fall on a plane. They literally call it like, dude, I swear I'm not making this up. They call it the plane of the horizon. The mainstream that we didn't make that up either. No one, like you guys made that up. The plane of the horizon. Google it. I'm telling you, it's flat, bro. The horizon, it's just a circle.
Sorry about that, Jeremy. I'm not trying to piss you off. I just keep losing signal. What were you saying though? You asked me if I
Oh,
had
you're
heard
good.
of
I know
something.
what it's like. Yeah, dude, the plane of the horizon. I'm telling you, just look
Yeah, yeah,
that
yeah.
up. They're even calling it a plane, just like I'm telling planes are flat. I'm telling you it's flat. They're telling you it's flat on a globe.
I mean, a name's a name, right? It doesn't necessitate a connotation with it. Like
It's just the horizon.
airplane.
Your horizon's flat, bro. I hear you. I hear you. But they are saying like your own mainstream guys are saying that it's flat, bro. And it would have to be, dude. Because like I said, you could get a basketball, and on a basketball they have a horizon. You know what I'm saying? You
Yeah.
draw a circle. You draw a circle where the horizon is, and then cut the basketball or a styrofoam ball or something you could keep inflated. Cut that off. The part you're looking at is going to fall on a plane.
Yeah,
this is how like a ball works.
I think you're confusing like if you looked in all directions, like if you had a 360 camera or something like that, then it would look flat, but that's not how perspective works, right? So if you're looking at a very small part of the ball, but the surface of it, you'll see it curve left to right. But if you then like turn left to look at that curved part and make that centered, then that part won't look curved, but left and right will again look curved.
Hey, look, I'm trying not to get triggered, bro. I'm not confused on this, dude. I'm not confused,
Okay,
bro.
let's just agree to
The
disagree.
I can do that, but I'm telling you, like
There we
in the
go.
Globe model, it's a plane.
Okay, that's fine. You can have that opinion. I'm not begrudging you your opinion.
Bro, that's facts. That's facts, dude. It has to be. It couldn't be the curving left or right. It can't. That can't be there. It's impossible. Physically, I don't care what it looks like. We're just talking about physically. It's
Mhm.
100% cannot be there. It's 100. It has to physically be 100% flat. The horizon on a globe.
Like that's kind of what I'm not understanding. Like it let me know if you just want to drop it at this point. But a basketball, when you're holding it far away, you can see like essentially a horizon where you're seeing like if it's far enough away, you can see 50% of the ball. That entire horizon is curved. Why would that be different when I get
It's
closer and closer and
physically.
closer?
It's not. First of all, the horizon on a basketball is not curved. Like I said, if you were to draw a circle where the horizon was, and then cut that part of, and then cut that part of the ball off. Let's pretend we filled the ball with styrofoam or something, and you cut that off. That would all the horizon part, the actual horizon. It would be on a plane. Planes are flat, bro.
Well, no, like just think about a picture of a basketball. If you're far enough away from it, you can see 50% of it, right? The percentage doesn't really matter. I
And
know
that
I'm bringing it up,
50%,
but it does curve.
the horizon of that 50%. That's what I'm saying. It doesn't matter how far you get away from a ball. It's always the
Yeah.
horizon's always going to be flat. It has to be physically. That's just how like it works. It's geometry.
I don't know. I'm looking at a ball and it looks curved. Looks like it's only got curve.
I know, but the horizon, like I said, if you were to cut the ball off at the horizon, wherever that may lie,
Yeah.
that part,
But our vision isn't cutting things.
your horizon would fall on a plane. It would be a flat plane. That's where the horizon would be. That's why they call it the plane of the horizon, because it has to be on a ball. That's how balls work.
Sure, like the horizon itself is creating like a hypothetical plane, but that's not what you're seeing. Like what you're seeing is a curve. You're seeing the curve around the maximum where you can see.
No,
So I mean, like
you're
just a
looking at
picture
a
of a ball, it
plane.
obviously curves.
It's, well, I don't know how obvious it is, but it's definitely not, it's curving around you, yes, but it's not curving any other way because it's on a plane.
Yeah, I'm not talking about the plane that horizon creates. I'm talking about the thing that you're actually seeing itself. That is like the ball itself is clearly curved.
But if we're talking about the horizon, you're just looking at a plane, flat circle. That's what the horizon is, dude. It's a flat circle.
I mean, do you get what I'm saying? Where like just think about a picture of a ball in your mind. Obviously, that ball has a curve. That's a ball.
Oh, you started roboting.
I might need to just drop out. My signal's not getting much better. Sorry, man. Can you hear me?
Yeah, I hear you now. I mean, we could save this for another day if you're in a better spot. I'm busy too working, so I mean, whatever you want to do. I'm just look up the plane of the horizon in between this for next time.
All right, I think I got better signal. Can you hear me now?
Yeah, I hear you. Dude, it's the same thing. It's the same thing when my guys say, show me the curve, this and that. It's like it's kind of supposed to be curving. Because when you're above a circle, you would see this curve you're talking about, a flat circle. Get a hula hoop. Get a hula hoop. And then look above the hula hoop. Yo, looks
Yeah.
like it's curving. Looks like it's curving, but we know it's not
Yep.
curving like that because it's in a flat plane. That's a good one, the hula hoop.
Yeah, I
That'll
think you're
that'll do it for
confusing
you.
two things because like your
Oh,
horizon
please,
does
bro.
create a plane if you have uh what's that?
Go ahead. Go ahead.
Like if you're looking at a ball that's at arms, you have a tennis ball that's arms distance away from you. You can obviously see that it's curving, but if you cut the ball where you can't see it anymore, like if you had somebody run a bandsaw through it and you said, okay, I can't see where the bandsaw is actually touching the ball anymore, then that would create a flat plane like you're talking about. But that doesn't change the geometric reference that you're seeing from your perspective. And you are clearly seeing a curve despite that horizon, what you're talking about, a horizon being flat. Like you're comparing 2D geometry to 3D because you are in three-dimensional space, obviously. So you're a distance away from that horizon line, that horizon plane.
I know, but dude, the horizon, that's what we're referencing for this. The horizon. That is just a circle. It's just a circle. Circles are flat. That's it. Like there's not like whatever you think is happening in that is you're whatever's happening with your vision, fine, we could talk about that after, but it is just a flat circle that you're referencing with the horizon.
I'm sorry, I'm getting like such bad signal. I'm gonna drop out. It was nice talking to you, Jeremy. I apologize if you can't hear me.
You're fine, dude. Just look up the plane of the horizon next time if you get a chance, and then we'll be able to maybe you'll get it. Like you were getting confused with level and horizontal or something. Like you were confusing me earlier with that. So I don't know.
Dyslexia. Sorry about that.
It's actually a frequent argument I have to have with Globers. Like they think the horizon's curving in this way where it never is for them. 'Cause this is how geometry works on a ball. It may look like it's curving, but tangibly, physically, in 3D space, it's not curving that way. That's why you'll never hear me say, "Show me the curve" when we're talking about the horizon, because on a if it was flat, it would still be doing that. Go get a hula hoop. Whoever doesn't think so. I came to this realization one night in Brandon's when he was debating Mr. Sensible about Bloom Age 2, I think, or whatever the balloon was. The guy was like, why is the horizon curve? And I was like, dude, it's supposed to be. And I went and set up some cans in the break room, put my phone in the middle of it, took a picture, went up a little bit, took another picture. Boom.